Gentlemen, welcome to lesson 3, first derivative test. Now, as always, all of this stuff was developed before electronic calculators. So a lot of this stuff you can do with a graphing calculator, but on a test or on homework, I expect you to be able to do it without a calculator and check with the calculator. Now, very important thing is the first derivative test. For local extrema. For local extremes. Now, here, f continuous function. If it's not continuous, we can't do it. And c is a critical number. Derivative equals 0, remember that? Now, two important points to note here. Well, as I said, if the function is a continuous function and it has a critical number c, then two things we have to note. First, if f prime of x changes from positive to negative, at x equals c, then f of c is a maximum, is a relative So if f prime of x changes from positive to negative at x equals c, then f of c is a relative maximum. Okay. So that means if you graph it, looks something like this. C, sorry, f prime of c, sorry, is a maximum. Here f prime of x is greater than 0, it's going up. And here f prime of x is less than 0, it's going down. So that's the definition of a local maximum. Once again, graphing calculator, you can do all of this, find the maximum point of the peak. Problem here is what happens if it's a weird graph, you don't know where to set your windows, or it might be just a little tiny lump somewhere that you really have to look for, or you might not be able to see on your calculator. So you have to be able to do this the hard way. Now, just to point out, of course, if we have a cusp, it's the exact same thing. Cusp or corner, we get a local maximum. This you can't derive, but, or sorry, it's undefined, I use the term. But it's the same idea. You get a relative maximum. So that's the first thing to note, or that's the first half of the first derivative test. Now take a wild guess what the second half of the first derivative test is. First two guesses don't count. Second part, if f prime of x changes from negative to positive, at x equals c, then f has a relative minimum at x equals c. Now notice I'm wording a little differently, but it's the same thing as part 1. So if we've got, I'll stop for a moment. If you've got a minimum like this, going down, going up. So that's a local minimum or a relative minimum, depending on who teaches it or which vocab they use. And of course, we've got a cusp or corner. It's the exact same thing, but this is undefined. So, first derivative test, you find the critical points. Well, so the function has to be continuous, and you find the critical numbers or critical points. So let's do an example. Okay. So let's find the local maximum minimum value for f of x. Equals x cubed minus 5x squared plus 3x plus 6. So that's your function. It's continuous. It's a cube. It has to be continuous. Find the critical values. Find the maximum minimum values. All right. So fairly straightforward. The derivative is what? Come on. Minus 10x plus 3. Now, pain in the bum, but this you can factor. So the critical values make it equal to 0. Now, honestly, I would cheat here, grab Mr. Graphing Calculator, and find an x-intercept. Or you could plug it into the quadratic equation, or you can find two numbers that a times c is 9, two numbers that multiply together to be 9 and multiply together to be minus 10. I'm going to do it that way just because I can. If you guys cheat, grab your graphing calculator. Anyway, so that two numbers, that would be minus 9x minus 1x. I'm doing it this way because I can. Okay, so when I factor it, I got that. I know I did that kind of quickly, I'm sorry. Once again, if I'm going too fast, pause the recording and follow along. But I got x minus 3 and 3x minus 1, which makes okay, so here's my two critical points, 3 and a third. Now, I'm going to stop there because I know I'm going too fast. Think about it for a minute. So my two critical values are at 1/3 and 3. So, then I look at my derivative. Now here, f prime is 0. I'm choosing a number in each section. F of 0 is the easiest. That's 3. Remember, we're looking at the derivative here. 3x squared minus 10x plus 3, that's 0. So this is positive here. In the second section, I'm going to do f prime of 1 because I can. I get minus 4, or a negative number. And in the next section, I get 11, or a positive number. Now, I just did table values in my calculator. Remember, it's for the derivative, the slope of the derivative, not the original function. Now, once you do that, you stop for a moment. You go, oh, positive to negative. It's the local maximum. And then you go at 3, it's minus positive, so it's going down, then up, local minimum. All right, now, so far so good. Now be careful, the other way I could word the question, not where are they, what are the coordinates? So instead of where's the maximum, where's the minimum, I could say what are the coordinates? And we just did all this work. So the local maximum is f of 1/3, and the local minimum is f of 3. So notice the coordinates of the function, not the derivative now, so we're going back to the original function. What's the coordinates of f of 1/3? Well, that's 1/3 cubed minus 5 times 1/3 squared plus 3 times 1/3 plus 6. Now, you guys got to figure out the math. So you figure out the coordinates for f of 1/3 and f of 3. Pause the recording. When you're done, come back and we'll talk about it. Okay, welcome back. So f of 1/3 I got as 6 and 13/27, so close to 6.5. So that is 1/3 comma 6 and 13/27. I know you gave me a decimal approximation. Check on your calculator. It's 6 and 13/27. Now, f of 3 is 3 cubed minus 5 times 3 squared plus 3 times 3 plus 6, which is minus 3, or 3 comma minus 3 is your local minimum. So this is the beauty of the first derivative test. It lets you find out exactly where you have maximums and minimums. Now, if you don't have a graphing calculator or you don't know where to set your graphing calculator, this is important. With a graphing calculator, it's kind of dumb. Well, I don't want to say dumb, but it's kind of redundant. Anyway, so take a look at this, and when you're ready, I want you to go on to the next part, which is find the local maximum minimum of Now that's the next part. When you're ready, go do that.